Hi everyone, I am Arisha Kashif and my teammates are Hazel and Ying. Today we're going to talk about the toxicity of cone snails. So, if we talk about their physical characteristics, they all look like cones. That means they are wide at one end and narrow at the other. Their shell bodies vary, they can be dull or very shiny. Their foot is normally strong and muscular, and they all have radula teeth. However, the size, the number, and the design of these teeth varies by species. They all have two tentacles on their head. If we talk about their habits, they normally live in shallow water, they hide in the sand, and they even live amongst the mangroves. Concerning the diet, they are divided into three major groups. Number one is piscivores, which are fish eaters. Number two is mollusciferous, which are snail eaters. And number three is wormivores, which are worm eaters. So, how do they actually attack their prey? They attack their prey by using a modified radula tooth and a venom gland. And via this, they paralyze their prey before engulfing it. This needs to occur in a very high speed so that the venom is delivered quick enough to exceed the escape time of potential prey, which include fast swimming fish. So, each cone snail species secrete a large amount of conotoxins, and these conotoxins act as neurotoxins. These are the most rapidly evolving protein coding genes. These peptides undergo many modifications after being translated. So, if we talk about the history of conotoxins, the first study of cone snail venomation was conducted in 1932 by Hermite after he was reported on a patient in the Seychelles Island. This patient was completely numb and he couldn't even move his body. Thus, Hermite dissected the snail and discovered various features which helped the cone snail in doing these kind of things and attacking their prey. In 1963, around 10 deaths were reported. This number greatly increased to 21 deaths after 20 years. Now Ying will talk more about the mode of action of these toxins.
As we know, the molecules of venom are too big to be absorbed, so cone snail will directly inject the venom into the bloodstream of human. Not only that, venom can't be absorbed to tissue because the stomach acid will mess up the venom peptide. Due to this, venom can directly distribute to its site of action and avoids the first pass effect. After the venom is injected into the bloodstream of human, it will travel to lymphatic system. To lymphatic system, this venom can spread all around the body and cause neuromuscular effects to glutamate, adrenergic serotonin, and cholinergic pathways, and also blocks nicotinoid receptor, which help us on skeletal muscle contraction. Some of the conotoxins will affect sodium, potassium, and calcium ion channels. At the same time, it will also affect our nervous system and causing respiratory paralysis at the end. There are many types of conotoxins available. Some of the conotoxins are highly lipophilic, while the others are polar form. All these molecules will undergo phase 1 and phase 2 reaction in metabolism. Phase 1 are included oxidation, reduction, hydroxylation, and hydrolysis to enhance water solubilities of venom molecules. This could help us on excrete the molecules of venom out of body. Phase 2 is the conjugations of amino acids with venom molecules to deactivate toxicant substance. These two processes are also called as biotransformation. Since conotoxins can be highly lipophilic or polar, so it will be excreted into two ways. Conotoxins that are highly lipophilic will be stored in edible tissue for degradation, and most of them will not be excreted out of body. Meanwhile, conotoxins that are polar will be excreted by urinary renal excretions. At the end, conotoxin will be excreted into urine by active secretions at proximal tubules of nephron. First symptoms of a cone snail sting is feeling a sharp picking sensation to unbearable pain. After that, the victim might develop ischemia, cyanosis, and even necrosis. Ischemia means inadequate blood supplies to organ, meanwhile necrosis means death for most cells in the organ. Several cases may involve muscle paralysis, respiratory failure, and leading to death due to cardiovascular collapse. Although symptoms can begin within minutes or take days to appear, but victims can die within 1 to 5 hours after symptoms of cure if not treated. That's all I have to say about it, and I'll pass it to my good mate Hazel.
For conclusion, so far there is no antivenom available for cone snail sting, but there are two commonly used treatments for people who encounter this. First is the pressure immobilization technique, where using an elastic bandage to wrap around the affected area. This is to prevent further injury or further spread of the venom to other parts of the body. Second is to immerse the affected area into hot water. This helps to relieve the pain after examination. Moving on, here are some recent research related to cone snails. First is the enzyme found in the cone snail venom known as conoyl P1, which helps to weaken the cell wall of ovaries and facilitate the entry of sperm. Thus, this result in successful reproduction. Moreover, journal Neuropharmacology have used fruit flies as testing and found that cone snails help with the development of nicotine addiction treatments and also new drugs for Parkinson's disease. All in all, we have seen cone snails do bring a lot of harm to us, but at the same time they do have their own advantages as well. Here are the references. In a nutshell, despite of the beautiful and also attractive appearance of the shells, we should always bear in mind to be careful because they could be very deadly as well. That is all from us. Thank you.